Hi there, welcome to my channel Maths SL. I'm speaking Thaqib Latif. This is front of me November 2020 question, calculus cubic graph question. The question says the graph of g of x is equal to ax power 3 plus bx power 2 plus cx. A cubic function having a y-intercept of 0 is drawn below. The x-coordinates of the turning points of G are -1 and +2. So these are the x-coordinates of the turning point and this is the y-intercept. First question says, for which values of x will G increase? Now must remember, we need to give answer in which value this graph G of x will increase. So the math start left to right. So the G is decreasing till this turning point. From this turning point, increasing, going up, increasing, and this is the second turning point. By the second turning point, again decreasing, decrease. So he want to know for which values of x will this G increase. So obviously between these two turning points the graph is increasing. So my answer will be between -1 and -1 is included, between -1 and 2. Told you whenever they ask about the cubic graph increase or decrease, then these both x values are included, the turning points value are included. 8.2 says write down the x coordinates of the point of inflection of G. So the point of inflection will he say find out the x coordinate. So must remember, I can take the mid. I've got two turning points, and if I take the midpoint of these two turning points x values, that will be my point of inflection. So the point of inflection, therefore x is equal to midpoint of these two x values, -1 plus 2 divided by 2. The answer will be 1/2. So the 1/2 that will be somewhere here, 1/2. So this is my x value of point of inflection. 8.3 for which value of x will G be concave up? This is my point of inflection here. So the graph is concave up till this point of inflection, and from here the graph is concave down. He looking where is the graph concave down. So I must remember he asked the question where G concave down. So the concave down, from here you can see the graph is from the point of inflection concave down. So therefore x greater than all the value on right hand side. So the x greater than 1/2, we have to look from the point of inflection because the graph change here. So x greater than 1/2, the graph is concave down. This is an interesting question. This is very high demand question. I like this question 2020 because a lot of nice concepts here. He say if first derivative of G is equal to -6x power 2 plus 6x plus 12, determine the equation of G. So he looking at the equation of the cubic graph. So first derivative is given. So how to find the equation of the cubic graph, I'll show you now. So you can equate the coefficients or you can apply the integration. So we have G of x. This is the equation of G of x, ax power 3 plus bx squared plus cx. So I'm going to take the first derivative of G of x. Then I'm going to equate the coefficients. So G of x, we have ax power 3 plus bx squared plus cx. So the first derivative of G is going to be a 3a x power 2 we are differentiating with respect to x. So the 2bx plus c. So this is the first derivative of g of x. Now, so he give us the, which is given the first derivative of g of x, he negative 6x square plus 6x plus 12. This is given. So the coefficient of x power 2 is 3a, coefficient of x power 2 in here negative 6. So 3a is going to be equal to negative 6. We're going to equate the coefficients. And here from here we find the a value, which is going to be a negative 2. And now the coefficient of x is 2b. 2b is equal to coefficient of x here 6 equal to 6. So b gonna be equal to 3. Now this is the c constant and and the constant we got 12 here, so therefore c gonna be equal to 12. Now I can put back the g of x, so therefore the g of x gonna be equal to, place of a I'm gonna put I'm gonna substitute a b c back into the original equation. So it's gonna be a negative 2 x power 3 plus 3x square plus 12x. So therefore this is my equation of the cubic graph. I put back a b c into this original equation. Apply integration. So therefore original function gonna be a g of x is equal to integral negative 6x square, which we got this function, plus 6x plus 12 dx. With respect to x we're gonna integrate now. So I'm gonna apply the integration. Negative 6 I'm gonna leave just like this. The coefficient x power 2 add 1 become x power 3 into the power you add 1, and then you divide by this power which you got 3 plus 6 coefficient as is x power got 1 plus add 1 more become 2, and then this power 2 you divide by this power plus, and the integration of the constant gonna be 12x. Now I simplify, I cancel. This is gonna be a negative 2x power 3 plus 2 divided by 3 is 6 divided by 2 is 3x square plus 12x. So this is plus 12x. So this is the equation of the cubic graph. Either way answer is same. You can apply integration or you can equate the coefficients. This is the last question, 8.5. The question says determine the equation of the tangent to G that has the maximum gradient. Write your answer in the form y is equal to mx plus c. Now must remember, I told you in my previous video, so this is a negative cubic graph, so we need to find the point of inflection. By the point of inflection gonna be a maximum gradient of tangent. I'll show you now. I explained in my previous video also, this is a very important concept. Before I solve this question, I need to show you this concept. Must remember, this is the cubic graph, positive cubic graph, this is negative cubic graph. Now the derivative of the cubic graph is, the first derivative of the cubic graph is parabola. You can see this is happy parabola, this is sad parabola. Now the minimum value is here at the turning point, and this is a sad parabola. So the maximum value will be here at the turning point. And the turning points of the parabola are the point of inflection of the cubic graph. So which means maximum gradient of the tangent will be at the point of inflection here. So negative cubic graph will be a maximum gradient of tangent, and the positive cubic graph will be a minimum gradient of tangent at this point of inflection. So therefore in negative cubic graph, at the point of inflection, maximum gradient of tangent, and in positive cubic graph, minimum gradient of tangent, that will be at point of inflection. So now we come back to our question 8,5. So we need to find the equation of tangent that has maximum gradient. When he talk about maximum gradient of tangent, that means that will be on negative cubic graph, and this is the negative cubic graph. So that will be on point of inflection, and that will be at the point of inflection. And the point of inflection we have here 1/2. So we need to find the tangent line, which is y is equal to mx plus c. So we're looking m gradient. So how are we gonna find the gradient? And we know at this point of inflection here, that is maximum gradient of tangent. So now this 1/2 I'm gonna put back into the first derivative to get this m, the gradient, because I need on this tangent line. So therefore x value 1/2 I'm gonna substitute into the first derivative to get the gradient. So the g, this is already given first derivative here, negative 6x squared plus 6x plus 12, we already proved. So I substitute x is equal to 1/2 into the first derivative, and then I get the answer 27/2. I use my calculator. So this is 27/2. So this is my m. Therefore this is my m, because the gradient of the tangent and the gradient of the graph, they are equal at the point of tangency. Now I need to find the y value. So I got the m, x value I got 1/2. So I'm looking a y value. I need to substitute points of tangency into this y is equal to mx plus c to find out the equation of the tangent line. Now to get the y value, now this x 1/2 I'm gonna substitute into the original function which we earlier proved. So the 1/2, this x value 1/2 I'm gonna put back into the original function to get the y value here. So I need a y value as well. So I'm gonna substitute points of tangency into the equation to get the equation of the tangent line. So I substitute x is equal to 1/2 into the original function to get the y value. So I use my calculator. So the answer is 13/2. Now I've got the gradient and I've got the point of tangency as well. I've got x value 1/2 and the y value got 13/2, and the gradient I have 27/2. So all of these three I have now. So now I'm gonna determine the equation of the tangent. I'm gonna use this formula, y minus y1 is equal to mx minus x1. So y minus 13/2, this is my y value, is equal to the gradient is 27/2, x minus x value got 1/2. Now I'm gonna solve. So this is gonna be a y is equal to 27/2x I use my calculator. So I'm gonna multiply 27 over 2 inside. It's become 27 over 2x minus, I use my calculator, 27 over 4. And this negative 13 over 2, I switch over this side, become positive 13 over 2. So I use my calculator. Therefore I use my calculator. The equation of the tangent is y is equal to 27 over 2x minus 1 over 4. So this is the equation of the tangent. This is my final answer. Please like and subscribe my channel. If you have any question, comment below. I will assist you. Have a nice day.